To round out our factoring strategy, we need to deal with a couple different things. Difference of squares, difference of cubes, sum of squares, sum of cubes. Basically, it's what to do if you have two terms. If you're factoring something that has just two terms, then really you've got four choices. So we've dealt with four terms, that was factored by grouping. Three terms had an easy case and a not so easy case. And if there's only two terms, then there's actually a lot of cases. So basically, though, after you factored out the GCF, you want to count the number of terms. 4, 3, or 2. If there's two terms, then you want to decide, are you dealing with squares or cubes? So if you're dealing with squares, things that are squared, numbers that are squared, then it's going to be this branch. If you're dealing with things that are cubed, then it's going to be this branch. And what you do and how you factor things beyond that is going to depend on the answer to the next question. Are the terms being added or are they being subtracted? So let's follow this branch a little bit more. If you're dealing with squares and you're subtracting them, so are they being added? No, they're being subtracted. So if you have the difference of squares, the difference of squares factors as a minus b times a plus b. And that's where we're going to start out in section 8.6. No, pardon me, 8.7. So, problem number 10. Y squared minus 49. There's no GCF. There's just two terms, and we're subtracting them. So start thinking about the difference of squares formula. It's helpful that on the left-hand side of the board, I've got the first 20 perfect squares written. You should recognize numbers like 49. Do you have to have them all memorized? No, but it's certainly convenient. Someone want to factor this for me? Good. Y plus 7, y minus 7. What if somebody else wrote y minus 7 times y plus 7? Which one's right? Oh, you guys are too soft. All right, yeah, they're both right, of course. Doesn't matter which order you write them. Both of them will work. Let's try some more here. Problem number 12. So what you're going to see is an increasing level of difficulty as we work our way through these things. Problem 12 is 16x squared minus 81. And kind of like the last one, you look for a GCF. Well, there's no GCF. So, okay, count terms. There's two terms. Are you adding them or subtracting them? Well, you're subtracting them. So start thinking about the difference of squares. What would you square to get the first term? 4, a little bit more. 4x. So I'll need a 4x here and 4x here. How about the second term? What do we square to get that? Yeah. So you need a minus 9 and a plus 9. And the order doesn't matter as long as you have opposite signs for both of those. Let's keep going with problem number 18. 64r squared minus 121s squared. Is there GCF? No. So, Sidra, what can I square to get the first term, please? 8r? 11s. So 8r minus 11s, and then 8r plus 11s. Nice. Thank you. Let's throw in problem number 20 here for something a little different. Change of pace. a squared plus 36. There's an important difference here. What is it? It's addition. So let's take a look at our sheet again. So are the terms being added? Yes. So that gives you the sum of squares. What's our sheet tell us about the sum of squares? It's prime. Sum of squares is prime. So we're done with that one.
That was easy.
Yeah, cool. So let's move on then. Let's take a look at problem number 32. And what you're seeing is kind of a progression of problems not much different than what you're going to see on the exam. You're going to see an easy one, a harder one, maybe a sum of squares, a prime one, and a problem like number 32, which is going to go a little bit further. 81 m to the fourth minus 256 n to the fourth. And wow, no GCF, but we do have two terms. 81 you might recognize. 81, that's 9 squared. But what would I square to get this term? M to the second. 256, wow, that's getting pretty big, all right? Not many of us have it memorized, but on the left-hand side board, what do you see you square to get 256? 16. So minus 16 n squared. What's the rest of this finish up as? 9m squared plus 16n squared. Great. On a test, if you left it here, you'd get 2 points out of 4. Go ahead. Which one? Good job, ladies. This factors a little bit more, right? Why? It's the difference of squares yet again, right? So this would factor as two binomials. How about this one? Does this one factor anymore?
No.
Why not? It's the sum of squares. Good. Sum of squares is positive, but the difference of squares is going to continue to factor, so it's going to be 3m minus 4n and 3m plus 4n. So that's your 4 points. So this is exactly what to expect on an exam, is a good variety of the sum and difference of squares types of problems. But it doesn't stop there. Let's do maybe one or two more here. Another good problem would be something like number 38. 8x squared minus 72. You look at that and you're like, okay, well, gee, neither one of those is a perfect square. I don't get it. What are we going to do? Any suggestions? GCF. Remember, the number one rule of factoring is to always factor out the GCF. So if I factor out the GCF, it's 8 times x squared minus 9, which leaves me with 8 times x minus 3 times x plus 3. Yay. So there's your sum and difference of squares. There's also the sum and difference of cubes. So a cubed plus b cubed, or a cubed minus b cubed. So we're going to have to factor these as well. Back on the kind of your handout, what you should be thinking of, kind of a diagram here. Are the terms being added? No. This would be the difference of cubes. If the terms are being added, yes, that'd be your sum of cubes. So two different formulas, and let me discuss those a little bit. help you remember some of these things. And I'm going to give you a couple tricks, a couple mnemonic devices. Extra credit if you can spell mnemonic. A cubed minus B cubed is going to be an A and a B, an A squared, AB, and a B squared. And the trick that I want to impress on you is remembering the signs that go in here. And the signs that go in here follow a specific pattern. These two are always the same. This one and this one are opposite. And the last one is always positive. So, nice little acronym there, right? SOAP. Same sign, opposite sign, always positive. Try and fill in the signs down here now. It's the same kind of formula, just different signs. Mackenzie, I haven't picked on you in a little while. What signs am I going to fill in here, please? Good. Plus, minus, plus. Now, when you're looking back at these, I'll give you one last little mnemonic. One negative sign per customer. The right-hand side of these equations has exactly one negative sign. If you have more or less, there's a mistake in your signs. But one negative sign per customer. Let's apply this to a couple of problems to finish off this section. So we'll start with problem number 54. B cubed plus 64. Now there's no GCF. 64 is kind of in a gray area because you can think of it as being 8 squared or 4 cubed. But what's going to tell you that you want to use the sum of cubes formula as opposed to the sum of squares formula? Yeah, you got a b cubed here, right? So you want to use the sum of squares or sum of cubes formula. So here's the trick. Let's figure out what I cube to get each of these two. What do I cube to get this? What do I cube to get this? 4. This is always going to be a binomial times a trinomial. Always. If you factor it as b plus 4 cubed, let me thank you in advance for making my grading job very easy. Okay? It doesn't work that way. It just will not work. But I'm going to use these two to figure out these three. Let's take this and multiply it by itself. B times b, b squared. I can do the same thing here with the 4. 4 times 4, 16. Now I've used these two to come up with these two, but I need one more. What else can I do with these that's different to give me one more? Yeah, multiply these together and get 4b. So once you get these two, multiply this by itself, and then those two together. How about the signs involved here? Lauren, what signs should I put in here? Good? Good. Same sign, opposite sign, always positive. And that's it. This will not factor anymore. It's just going to be, you're just going to be stuck with a trinomial, and that's it. Any thoughts on problem 54 here? Yeah. Well, I'll tell you what. How about if we multiply it out, that is if we distribute it, and see if it actually gives us what we started with, okay? Will that be helpful? All right, so let's do that. Let's start by distributing the b. b times b squared would be b cubed. What's b times the middle term going to give me? B times, well, I'll have a b squared here, right? So I'll have a minus 4b squared. And then b times 16 would be a plus 16b. So far, so good? Let's distribute the 4 to both of these terms, or to all three of these terms. So 4 times b would be a 4b squared. What's 4 times the middle term? Negative 16b. And then 4 times 16 is a plus 64. When I add these terms together, can you see something special is going to happen? Those cancel out, and these cancel out. You're left with b cubed plus 64. So it looks strange at first glance, but it does work. Does that help out? Okay, good. Let's see. Let's try. Let's try problem number 60. So we'll jump up to kind of a harder one here. So 8 c to the 6th minus 343 w cubed. There's no greatest common factor here. So what next? Next you look at the number of terms. How many terms am I dealing with? 2 terms. So because I'm subtracting and I'm dealing with 2 terms, it's either the difference of squares or the difference of cubes. I'm hoping that you can see by the w cubed that we're going to end up dealing with the difference of cubes. The hard part is going to be figuring out what we cube to get this part. In addition to the first 20 perfect squares on the left-hand side board, somebody handsome, athletic, really intelligent, and modest also left for you the first 10 perfect cubes. So let's take a look at the left-hand side. What do I cube to get 8? 2. Then I need to cube something to get c to the 6th power. Has to be c to some power. What do I multiply 3 by to get 6? So it's going to be a 2c squared. How about the next term? What am I going to cube to get 343? 7. If you're not sure, look at the left-hand side board. You can also take out your calculator and start trying a few things. You can do 5 raised to the 3rd power is 125. No, that's not enough. And then work up the ladder. 6 raised to the 3rd power, etc. And then finally you hit upon 7 raised to the 3rd power. That's 343. So 2c squared and 7 what? 7w. Now again, you're going to have a binomial times a trinomial. Multiply the first term by itself. 2c squared times 2c squared. That's going to be your first term here. What do I multiply to get the last term? Thank you. 7w times 7w. Then I'm going to need the middle term. 2c squared times this. So I'm using these 2 terms to come up with these 3 terms. Rachel. Can you help me fill in this trinomial? 4c to the fourth, good. W times W squared. All right. And then I think you at some point must have used same sign, opposite sign, always positive. Thank you. So 2c squared minus 7w plus 4c to the fourth plus 14c squared w. Now just so kind of a heads up, in your factorization, you shouldn't have any exponents that are bigger than or even equal to these exponents. They should all be smaller, so that when you multiply them together, you get the bigger numbers, the bigger exponents here. All right, that one was kind of challenging. Let me give you one a little bit more relaxed, a little bit easier to work with, and that would be problem 70. 2x cubed minus 128. What's your first step in this? You're not seeing 128 on the list of perfect cubes, are you? GCF. Always, always, always factor out the GCF. What's the GCF in this case? 2. Leaving behind x cubed minus 64. That 2 stays out in front. You have 2 times a binomial times a trinomial. Dylan, what 2 terms are in the first binomial? What do you cube to get each of these? What do you cube to get 64? Thank you. 4. And then what would I put here? What do you cube to get this first term? Just x. So, take the first term, multiply it by itself. X times x gives me an x squared. Take the last term, multiply it by itself. I get a 16. I've multiplied the first term by itself, the last term by itself. The only thing I can do to get something different would be to multiply these two together. X times 4, we'd probably prefer to write it as 4x. Amanda, what signs are going to go here? Same sign, opposite sign, always positive. Nice. 1 negative sign per customer. So if you accidentally wrote 2 negative signs or no negative signs, go back and fix things. For homework, try 9 through 31, 37 through 43, 53 through 59, and 64. No, let me just check something. Yeah, 69 through 87. did I not? I will go back and get that. As always, these are just the odds.